All right, we are live, finally back in action. So we have Jamie Winsor on with us today to talk about his discovery project. And my loose understanding is it runs on what the Raft protocol. And maybe Jamie, you can tell us a little bit about what it's for and how you can build out distributed infrastructure with it.
Sure. Thank you very much for having me on, man. But basically, the problem that we're trying to solve is Erlang nodes by default, when you connect them, are fully meshed. And the problem with that is I've heard varying numbers, but 50, 100, or 200, or 250. Once you get up to a certain amount of nodes, they can't stay connected anymore because they're spending all their time telling each other that they're connected, right? So a way you can get around that is using hidden nodes. So a node joins, says, "Hey, don't tell anybody else about me. I just know about you." You can make a network of hidden nodes. Well, the problem with that is then how does anyone know about anybody to send them a message? So a company called HashiCorp, they had made Vagrant and a couple other great tools, introduced Surf and Consul. And Consul is a service discovery tool that sits on top of the Raft protocol that gossips about particular events or nodes or whatever you want. And Consul specifically for service discovery. So my goal was to leverage Consul to automatically discover Erlang nodes and allow us to avoid having a fully meshed network. So specifically, this tool was built for an online game that I've been working on with my company, Undead Labs. It's called Moonrise, and it will be out early next year. What we wanted to be able to do was create a very horizontally scalable infrastructure that was very easy to configure and didn't require a whole lot of that effort because we don't have an operations team. So we leverage tools like Chef, Consul, and just Erlang and OTP in general, and how great that is to allow us to have very fast deployments, no downtime, or we're hoping no downtime, and the ability just to add another node and say, all right, EC2 or whatever our cloud provider in the future is going to be, turn on a new node and add it to the cluster, and let's get going. So basically, what Discovery does for you is it starts a OTP application. It connects to Consul, and you start a poller, and you start telling Consul, like, I'm this service, and this is where I am. Sorry, that's the heartbeat. You say, I'm this service, and here's where I am. And then for people that want to consume that service, they start a poller that talks to Consul and says, okay, where is this guy? Where is he available? Or where are all the things that are running the service? And then there are handlers that you can create and put into the poller. So when it finds a new service, it'll take care of connecting or doing whatever the job is. Specifically, there's a couple that come with Discovery, and one of them is the node connector poller. So basically, when a new node pops up, we leverage Erlang's ability to connect to the node, monitor the node, and then auto-retry connections, auto-retry if disconnections happen, and you can also, like I said, add a handler that does anything. So as soon as a new node is found or the connection is reconnected or disconnected, you can register events that allow you to do a particular thing. This so far has allowed us to do things like find databases that, if you a master-slave failover, you can reconfigure Ecto to connect to the different database. It's allowed us to, like I said, add an additional routing server or add an additional account server to our cluster, and it's worked really well for us so far. We've been using it in production now. We're not live, but production-ish environments for about 4 months, 5 months, with a lot of luck. That's the open source bit. The other bit is like hey, now that you have this fully connected network, how do you talk to everything? And for that, I don't know if we're going to be able to open source this stuff, but we can still talk about it. It's basically some of the nodes know about all the nodes, and those are routing servers. So if you want to send a message from one account server to another account server, you have to first message it to a routing server, and the routing server will route it to the other account server. That account server will do its business, message back over one of the random routing servers back to the account server. So those are distributed transactions. They're trivial to implement, but it's not generic enough to open source. I don't think that's the problem. So I think a blog post or a talk will happen instead around that. But a combination of discovery and those distributed transactions allow us to create an infrastructure that can horizontally scale to hopefully any size. And,
Yeah, that sounds awesome. I know that you found me after my talk at ElixirConf, and it's kind of like exactly what I would love to accomplish long term. And you have it in production right now.
yeah.
And I don't know, could you show off or talk about any how the hooks work exactly? Like if I have this node running with a service, how would I actually write code around that? Like what would the client kind of look like around perform this action? Some other node. I mean, I guess strictly in Elixir Erlang terms. If you have a couple nodes and they each register a service, how do you write code around that as far as discovery is concerned?
Yeah, sure. Let me see if I have something here that would be a good example. I guess I could have been a little more prepared. Let's see. Where's this? Nope, don't want to turn the camera off. I want to share my screen. There it is. All right, can you see this? All right. So this is not an open source project, but I can show a couple of the files for it that'll be an example. So this is a routing server. It starts a supervisor, and let's start.
Up a tiny bit or quite a bit.
Oh, you want me to blow it up?
Yeah, maybe just 4 or 5 font sizes. Be a little easier to see.
How's that?
A couple more.
Yeah.
There we go. That's good.
All right. Sorry, I can't see it very well in the video. So what we have here is one of the routing servers that I was talking about. Like I said, this bit isn't open source, but I hope to be able to at least give a blog post or talk about it if I can't come up with a generic way to open it up. But you have a heartbeat that runs, and the heartbeat is going to run a particular check, a service check. And these are for Consul. You define a service check, and then you talk to Consul and say, hey, I'm passing my service check. And what it's going to do is every X amount of seconds go ahead and report that you're alive. That's what this TTL is here. And then the router wants to know about the other routing servers. So it'll then look for a particular service, and this is one of the handlers that is going to run if it finds that service. And then you can look at, say, I was mentioning the account servers. And what this thing's going to do is two things. One is it's going to run a poller that does node connect, and that is the thing that makes sure that the connection is standing and reconnects when it goes down and the node's monitored. And it's also going to go ahead and on connect run another handler, which is a route connector. And this thing's job is to broadcast particular shard IDs that the account server supports. We use Instagram's sharding model, which means that we split our data 128 times into buckets. And that allows us to take a database and move it into onto another physical database machine. So basically, we'd have, say, 2 Postgres databases at first, and one of them has 64 and the other one has 64 shards. And then if you want to split that again, you add another database server and move the shards, which is specifically Postgres schemas, into another Postgres database, start another app server, and it now hosts those particular shards. This is important for our routing cluster because the routing servers need to know what shard you're trying to talk to. So this is a way you can customize on Node Connect with Discovery how to do additional things. So if we looked at the route connector, you see that when an on-connect happens, we're broadcasting the fact that we're available and we support particular shards. So this is a way you can customize it. So let me show you really quick in Discovery what the basic node connector looks like. And this is the open source code, so this should be easier to talk about and demonstrate. Let me share this screen again. Come on. All right. Good. The font is still large, I think. All right. So this is the basic node connector. When we add a handler, or when we start, we can pass handlers to it. Yeah, handlers can be added like any other gen event handler, just the module or the module and args, or you could pass it multiple different handlers if it was a module and a ref. Basically, all that's going to happen is this thing's going to sit in a polling console service health, and this is a long poll. And when we get a particular change in services, we notify a gen event, and that's node connector and any other handlers that you've defined, and that'll run and take care of actually connecting the node. So I think, yeah, this is the event that gets fired and then notifies, and then node connector is the thing that picks it up. I think if we look at the README, the documentation is pretty good. It's a little bit easier to understand than me kind of sitting there and going through doing a deep dive of the code. But I guess the first step that you need to do to start using or publishing the service status is you have to install the Consul agent, and you have to set up one of those service definitions. And that's the thing that your heartbeat is going to talk to. So if we set up a service definition and we say it's for this particular application, this is how long we want to wait until we consider the service dead, and then we add some tags, which is specific for node connector. This stuff's picked up as well and passed along into the handlers. This will say, this is the name of the node, the Erlang node that we're going to actually try to perform a node connect to. Like I said, if the TTL is not met, that service will just go down, and people will attempt to connect to it, but it'll be a failed connect, and then we'll just retry it. So I kind of showed you one of the supervisors already in the previous code example. And then this is the other end, the polar. So I think we looked at that already. These are the polar handlers. We went over those. Let's see. Oh yeah. So once we're connected, what do we do? Like, how do we talk to particular nodes? And by default, all the nodes are joined into a consistent hash ring. So you'll attempt to randomly select or consistently select something by using discovery.select. And like I said, that all the nodes are sitting in a consistent hash ring. So the first value in select is the application you want to talk. The second one is a hash value that'll get consistently hashed, so you always talk to the same node in the cluster. The only downside of this is that if you add another node, you'll be potentially selecting a different node when you run this function. So you have to be careful and make sure you understand the implications there. If you didn't want to use just the consistent hashing, it's really easy to implement a different way to talk to the nodes, and that was the other side of things, where we had the sharding mechanism that's deterministic. So there was 128 different nodes that you could talk to, right? And using the handlers in a way in Discovery, you could register particular shards, like I had shown in the previous example, and then you can just use those directories to talk to the different nodes. But this is what we started with, is the consistent hashing mechanism. I think those are all the basics and a little bit of rambling on top.
Yeah, that sounds awesome. So I did have one question. So you mentioned being able to, I think this was part of your like proprietary stack, but you were able to set up like a node just to handle routing in between different clusters, kind of.
Yeah.
That's how you avoid like with the N100 or Node 100 problem, where if you get over 100 nodes connected, the Erlang basically can't deal with it. So you basically, the way you're deploying your architecture is just having Consul and Discovery sit in between different clusters, and then they just kind of all talk through like different routers, or how's that?
So
understanding.
Yeah. So specifically, well, with Discovery, you're going to avoid no matter what the fully meshed network, because the nodes all connect to each other in a hidden way. So you won't need to worry about the fully meshed problem. But then the problem is, how do I talk to the nodes, right? So the routing nodes exist in our cluster to allow you to bounce messages off of them to other nodes. So somebody's going to know about everybody, or nobody will know about anybody. So you have to make one of the types of nodes talk to another type of nodes of that same type, and we just happen to call them routing nodes. But if you set them up in this way, if you made a type of node called router, you would have the exact same thing that I have as well. It's just a pattern, right? So some of the nodes know about the same types of them, and those are the routers. They're fully meshed. And then the other nodes don't know about the other types of themselves, but they all know about that type of node. And the router knows that the router is those nodes that you can reliably send messages to. And because of that, you then know how to talk to the other types of the nodes for your peers. So you can bounce messages off the router. And the code that isn't open source is basically the distributed transactions across routing nodes.
Yeah, I imagine trying to open source something like that, making it work for broad use cases would be impossible. That makes sense.
It's really hard to open source that so far. Also, we've been working on our game for a little over a year and a half now, and the Elixir work started in '09, and we, we've not had the time yet probably to go through the code base and say what can we make more generic and helpful for people. Discovery was one of the first things that we open sourced because it was a pretty obvious chunk of work that we could do and hand out and get some people looking at it and using it, and hopefully help us out, because this is a problem that Erlang has had for a while, and I think this is a way to solve that problem. The guys at Erlang Solutions, Francisco, was having a chat at ElixirConf with me about a way that they're attempting to solve the problem as well. They've got a really good plan, but I think that their plan is going to take a damn long time to implement.
Gotcha.
Or at least for one person, it would be a long time to implement.
Right. Awesome. So I guess long term, do you have any big changes? Or I know I'd love to see blog posts and maybe some conference talks about this, because this sounds like what you're saying could be a really big thing. So I think that's having an easy way to manage clustering is kind of what I'm after, but I haven't even begun to start thinking about how I do it. It sounds like you're successfully doing it, so I'd love to see more information. And do you have? I briefly checked out the README. I haven't had a chance to try to get anything up and running with Consul and Discovery, but is there any kind of best place to get started that you'd recommend, or any documentation or blog posts that are out there yet?
Yeah. So the problem with this stack is there's a lot of knowledge that you need to have about external services before you can really get going. Like just installing and getting Consul up and running is an afternoon. Figuring that whole bit out. But the docs on Consul's website, consul.io, consul.io, are very, very good, and it'll give you a quick run through of how Consul works, how you can connect things together, how you can configure things. If you're familiar with Chef, there's a cookbook that I've been contributing to. It's the one on the community site for Chef, and it's in really good shape. It's allows you to define new service definitions in line and install Consul and configure it for Ubuntu or Red Hat. So if you go read the docs about Consul and then jump on that cookbook, it's a really great abstraction to get things configured and installed for you. I'd highly recommend that. That'll get you there with Consul. And then the README for Discovery should be up to date and pretty good enough to get you going to a point where you'll say, oh, all right, I now have these machines that are auto-connecting together and auto-discovering each other. Now what do I do? And I think that's the first place to get. Like, these are primitives. These are both primitives to build something else. And the routing mesh, or the routing layer that we have inside Undead Labs' proprietary stack, is something that you could build on top of that. And honestly, it was not nearly as much work as the primitives were. So I'm hoping that people will either figure it out beforehand or this year. I'd like to have 2 different talks that I give on a couple different places that cover more of the chef and automation side of things, and then the other side is the how you can build distributed fault-tolerant Erlang applications on top of Consul, and then a little bit of how you can automate it and deploy it with Chef.
Awesome. Well, I know so ElixirConf is coming up sometime around April next year. The RFC hasn't gone out yet, but I'd love to see you give a talk out there, so you should keep an eye out on that.
Yeah, that would be good timing. I think that would be great timing. Cool. Really, it's going to be in April instead of, it's like August this last year.
Yeah, it'd be April. This is the ElixirConf Europe.
Oh wow.
I'm out there. Yeah, we'll see. No details have been released yet, but I believe it's sometime in April. So it's the next opportunity.
Yeah. Is it? Are we gonna do it in Austin again in America?
Yeah, I think that's October next year in Austin. They've already set a date. I'd have to double check. But yeah,
That was so hot when we went in July or whatever.
yeah,
Oh God.
not quite used to that. But cool. So where can folks find you online if they have questions or want to check some information out?
Twitter and GitHub are the best places. My GitHub is reset, R-E-S-E-T, and Twitter is reset existence, all one word. Yeah, but also I'm in IRC on Freenode as reset as well, typically. But any issues, super welcome on Discovery. If anyone's using it for anything that they'd like to share, that'd be great. Like I said, it's a primitive to try to help people out. It's not a thing that's going to solve your problems immediately. It's hopefully a thing that's going to help you solve your problems later on. I'd love to continue to support it and get some feedback about what people are trying to do with it and expand and solidify and further document the primitive.
Cool. So I think as far as upcoming events, we mentioned ElixirConf, and next month we'll try to line up some other speaker or topic. I know that there's a lot happening since Elixir went 1.0, so there should be plenty to talk about the next several months. So appreciate you talking about Discovery. I need to set aside some time to really check it out because it sounds like everything I outlined in my talk. It sounds like that you solved it with Consul and Discovery together. So very cool.
Yeah. Well, thanks very much for having me on. We're using. What'd you say?
I had a Q&A, but I forgot to enable it. So normally we have folks asking questions, but if you have questions, just go ahead and drop them on Twitter and at Reset Existence, and we can continue the discussion there.
We're actually using Phoenix in the stack as well.
Oh, can you talk a little bit about that? That's pretty cool.
Yeah. So we're building online games, and Phoenix is used in the back end for our administration tools. So players won't ever see this, and unfortunately, you'll never see it. But Phoenix and Ember.js with WebSockets to maintain a persistent connection and then talk to the routing cluster to get information out. So it's basically like another client almost talking to the backend service. And it's worked really well for us so far. I think almost all the problems that we have are around deployment, not deployment, building of releases. Like a lot of what's the best practice right now for getting everything together, compiled in the right place, packaged, and then incrementally upgraded outwards. I think that is still that's the biggest pain point that we have. It's solved in a way. It's just not to the point that I'd like to be at.
Gotcha. So are you using Phoenix channels at all, or are you doing direct WebSockets in through plug?
I'm pretty sure they're channels. So the project is like 8 or 9 OTP applications large, and this is one of them. And another guy on my team's the guy that heads it up. But I laid groundwork and helped out the beginning, and now it's a thing that's just working that I don't need to worry about. I just turn it on, and I'm like, oh great, it just works. Great.
That's the goal. But it's cool. Yeah, I'd love to see how you guys are integrating Ember with it, because I know someone on the Phoenix issues wanted to start work on a Ember data adapter for Phoenix channels.
Yeah, I will.
It'd be cool to see how we can wire those up and get things talking.
Yeah, M. Gamini, I think, is the GitHub name of the guy at my work that is working on the Phoenix side of things. But Phoenix and Ecto we use quite a bit, and we've had a lot of great luck with those. It's an evolving language and community, and we're very aware that we adopted Elixir at 0.9 and have upgraded as every single release came out, and we are very glad that it's at 1.0 now because we don't need to, like going through and replacing all the records that we had with structs. It's a big thing.
It was worth it, right?
Yeah.
It was a rougher transition, but I'm pretty happy with where we ended up.
Oh yeah, I mean we've got a very stable code base at this point that is enjoyable to work in. So, I couldn't ask for more.
Awesome.
Yeah, I haven't gotten any messages on Twitter, so I'm not sure if anyone has any question at this point. Maybe we'll watch it later.
Yep. Yeah. This will go up on YouTube pretty much within the hour. I think it's usually pretty quick. And go ahead and just direct questions on Twitter at Reset Existence. And that's all we have for today. So we'll catch up next month. The date is slipping my mind, but just follow Dayton Elixir, and we'll get a tweet out. And thanks a lot, Jamie. It looks really cool, and I can't wait to check it out.
Yeah, no problem. Thanks for having me on, man.
Later.
All right. Have a good day.